So hi, everyone. As mentioned, I'm Sarah, and I am an MArch student at the U of T Daniels Faculty of Architecture, and I'm presenting my thesis today. Super happy to be able to kind of present it right before the final deadline in just a couple days. But my project is called Lightopia, a hyperplenum of embodied light. And it's a very dramatic title, but the premise is to basically question the potential of responsive architectural elements to modulate light within spaces, and do that in order to accommodate adaptability of use and flexibility of how spaces are used. But to kind of bring that back a little bit, my interest in kind of how spaces modulate daylight kind of comes from some of these precedent studies, such as like the Kimball Art Museum, which has the skylights and the baffles to kind of diffuse light, bounce it around. We have the Bogsburg Church, which has this voluptuous roof to diffuse light as it comes into the space, whereas the Kunsthaus Bregenz uses this material property of the space to diffuse light as much as possible. But something that I noticed within all of these projects is that there is an inherent staticness to this architecture in spaces where we're existing and we're changing what we're doing, especially now that we're in a time of COVID and our spaces need to instantly adapt to, different programs. I find that our architecture is quite static for that purpose. And to kind of, dive into that a little bit further, I've been making these graphs that are mapping a 24-hour period in a person's life, where the yellow represents the amount of daylight that they get in the space, where the light blue represents the amount of artificial light that they're able to control in their space, and the dark blue is the amount of light measured in illuminance that they need for specific activities. So in all, to say that in making these graphs and mapping different types of days and different types of people and different types of spaces, the idea is to hit home on the fact that the amount of light and the quality of light that we have in our spaces may not always kind of measure up to what we as people and inhabitants need from our spaces. So my proposal in my thesis is a hyperplenum, which is this actuated surface that is attached to a plenum of a building. And what it essentially does, it just harnesses daylight from outside, embodies it within the plenum, and distributes it where it's most needed within that space. And to kind of put that a little bit more diagrammatically, as I was mentioning, the hyperplenum is able to harness light. It essentially acts as a large light tube where it captures light, transports it within the system via highly reflective materials, modulates it according to the geometry of the plenum, and then delivers it where most needed. And to kind of dive into, what are the tectonics of the surface and what do they look like, I've been creating these prototypes, scaled prototypes of what this surface might look like. And I arrived at these auxetic surfaces, is that what they're called? And what they essentially are is a flat sheet material where you cut a pattern into it. And once you start applying forces to it, they can expand and contract as you may like. So it's essentially a pre-programmable material. So this is the pattern that I came up with that I found most compelling and that I developed using a grasshopper script. And just to kind of give you an idea of how much I'm able to control with this pattern, I can control the size of each nodule, the hinge size, and the angles of the hinges as well. All in all, to say this is a pattern that I was able to develop and apply to a surface. And you can apply it in a variable format. So as you can see, the pattern changes throughout the entire surface, and this kind of results in a varying varying amount of light being able to enter a space. So the light modulation aspect of this pattern actually happens through the size of the openings. So how much pressure is being applied to the surface, and of course the material properties, how reflective or diffusive or absorptive it is as a surface. And to kind of like, dive into a little bit of how this system might be actuated, the idea is that the surface gets held at the corners, and then using a piston system or weight-based mechanics from the ceiling surface that push down onto the surface, you can create this like undulating landscape of sort that varies the amount of light coming into it. And just to kind of give you a quick view of what that might kind of look like in the space. Just as a quick note, this is an animation that I developed by creating the script in Grasshopper and then taking the surface, the auxetic surface, into Blender to try and simulate what the physics of it might actually translate into reality. So that's where this animation is coming from. But to talk a little bit about achieving quality of light, from my understanding, the way that we measure light in, for example, the LEED building standard is using the spatial daylight autonomy metric. And what that denotes is a very binary, you have light in a certain percentage of the room versus you don't in the other. And that's how we measure a well-lit space. However, I think that perhaps like we can build a little bit more of a nuance to it by perhaps using a system like the Plenum, where you're able to measure illuminance and kind of create this atmosphere that isn't quite as binary as we might think it to be. So just to say, I've been conducting some daylight experiments to see how much daylight penetration you can have into a space, how spaces that exist might have a daylight problem, especially large spaces such as exhibition spaces or, for example, IKEA. Even spaces with smaller footprints that have a lot of windows can have, I think, a light modulation problem where there is a bit too much glare. And, also testing out what can a system like a light shelf achieve in terms of bringing daylight farther into a space. All in all, to say that, to kind of culminate those thoughts into what can I achieve with this hyperplenum surface that I have. And just to say, because of how I'm restricted to the computation power of my laptop, I did indeed actually have to flatten out the surface to be able to simulate it. And the results are kind of like one of the ones that I produced was something like this, where you can see the clear stories and the plenum kind of acting as a light shelf and bringing light into space, and perhaps an initial idea of how this surface might be able to modulate the light in patterns across the space. Just as a quick mention, I forgot to say that all of these simulations I've conducted in Climate Studio. I've been lucky that one of the instructors at school is Alston Jakubiak, who's one of the developers of the program. So in accordance with some of his guidance, I've been able to kind of conduct these simulations. So just to go forward, I understand that I've been working on this for the last few months, and it's not a very rigorous testing of the system that I've conducted. But if I were to kind of continue on this path and really develop what this surface might look like and simulate it to the nth degree, what the types of conclusions I might be able to draw are, what are the size of the openings that the surface needs to have to allow for adequate light to enter the space? What is the density of the pattern? And what are the materials of the surface itself? Which then brings me back to this image that I showed you earlier, which was the hyperplenum. So as you can see, it's a surface, an actuated surface that I'm gearing towards large spaces that have a daylight penetration problem. and kind of being able to create like a whole host of, different activities and programs happening within that space. And with that, I will leave you with this animation, which is kind of my attempt at showing what that atmosphere might look like and what this service might look like once it's being actuated within that space. And that is it for me.